Here we go. Mark your own. Oh, my students get to see their favorite, well, Mr. Duick's favorite student anyways. She's back. You'll explain the joke to other people later, and Sirky. So for you to get full marks, I need to see the resultant and an arrow on the end of the resultant pointing in the right direction. If you didn't put the arrow on, I would take a half mark off. So we did number 1 together. Number 2, well, if 3 plus 6 is 9 and 6 plus 3 is 9, if order doesn't matter when you add with numbers, order shouldn't matter when you add with vectors. I should get the same vector. Let's see, that's going to be down first and then sideways. And yeah, I get the same resultant. That would be my answer for number 2. Number 3 was a bit trickier. C plus B. Okay, well, oh, Mr. Duick, you forgot. You better pause your video for just a second. So I'm going to draw these tip to tail. So I said, okay, I guess vector C looks like this. Vector B looks like that. And I guess if I go tip to tail, that should be the resultant. Yes? Then I noticed number 4 was the same as number 3, but a different order. So I should get the same resultant if I go down first, then go sideways, and then from the tail of the first to the tip of the... Yeah, I do get the same resultant. So there's number 4, B plus C. A plus C. I said, okay. Tip to tail, Mr. Duick yelled. Said, there. I guess the resultant is going to be not as steep as the previous 2, but still slanty down. That's number 5 right there. If I was clever, I would do something like that. How's that? Number 6, how do I add 3 vectors? I guess I'm going to go tip to tail, tip to tail, tip to tail. So I said, okay, here's A, there's B, there's C. I guess the resultant is going to be kind of that, something along those lines, I think. Spence.
I added them like you did in
yeah.
the previous lesson, so I did A plus B is this line. And
yeah, and you got the same thing, right?
That line.
Yeah. You got the same thing?
Yes.
Yeah.
Didn't have them all together in one
yeah.
thing. But two separate. I got a very different answer.
Okay, I'll show me later. We'll lawyer with me after. Number 7, 2A. Well, I said, okay. That's 1A. I guess 2A is 2 of them. And if you drew a resultant over the top, that's fine. But that's clearly, I think 2A's is 2 of them tip to tail. Number 8. Okay. If you drew that, that's fine. Or if you were really clever and you said, I think it's just 0, which it is, as a vector, that's what 0 would look like. You end up back where you started from. We may run into that later this year. We may look at a situation where something isn't accelerating. If an object isn't accelerating, what's the net force? Who remembers from last year? 0. And when we add the forces together, we'll know 2 of them, and we'll add them tip to tail. But since it's not accelerating, what must the net force be? We can reason that the third missing force has to be that, because that's what takes us back to where we started from. A closed vector triangle where you end up back where you started from is a 0. That must be what the net force is. I think we'll get there this year. I hope we'll get there this year. That's in our equilibrium unit, but we'll see. B plus D. I said, okay, B plus D. Oh, I guess like that. 2B. I said, okay, 1B, 2B. And if you traced over it with a resultant, that's fine. Yeah. Yep. I'm okay, yep. 2C. Yep. Yeah, if you just drew one big line, I'm good with that. Ooh, 2a plus d. Well, 2a would be 2 of those plus d. You know what? I think that's the same as 1a. If you drew the resultant, it would be that. Can you give yourself a score out of 12, please? And if you need a lawyer with me, now is the time. Last day we talked about, Deegan, how do you add two vectors together? How do you add two vectors together, Deegan? Draw them. Draw them.
How do you draw it?
Deegan, oh boy, we're getting out the Nerf dart. What? Okay. Today we're going to reverse the procedure. I'm going to ask you, what if I give you the slanty vector, the 12 newtons at 42 degrees north of west? Can you come up with the original vectors that it came from? We call those components. Recall, I was only a scalar until you came into my life and gave me direction. You are the vector of my heart. Wouldn't that be a good love song? That should be a song. Oh, that would be so good. Okay. Example 1. A person walks 6 kilometers north and 4 kilometers east. What is their distance traveled? Kessler, you'll notice I only gave you a line or two, which usually means I think you can do it in your head. What distance did this person travel? Yeah. What's their displacement? Well, now I'm going to draw a compass rose. Now, the other thing that you can do, if you're still a little shaky on the trig, I know when I taught math in the trig unit, in the same way as like last year I made you do a free body diagram, in the same way as this year I'm drawing a compass rose, every time my kids turned the page, I made them write at the top of the page. So it's up to you, but look, if you're still having trouble doing as much as I am in your head, do that. I mean, give yourself a break. What is their displacement? How am I going to do this? I drew a compass rose. Now I'm going to dope. 6 kilometers north plus 4 kilometers east, about half as long as the 6. Deegan, how will I draw these and add them together? Draw them tip to tail, you say. I could have drawn 4 plus 6 and you'd get full marks. Typically, Liz, I'll draw them in the same order the question gives them to me, unless it's clearly obvious that it's going to be way easier to draw them in the other order. And once in a while, that will be obvious. Then I might say, oh, this is a terrible drawing. Let me draw the other one first. It's just so much simpler to track. But for now, if you want your work to look just like mine, that'll same order as I draw them. From the tail of the first to the tip of the second, this is their displacement. Solve this on your own. I'll solve this here. I'll race you. Theta goes there. Color, 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 color. Oh, I forgot to put the 4 on the triangle. If you said 34 degrees, that's fine. For some reason, because there was a 9 there, I bumped the 6 up because, ooh, that seemed somehow more accurate to me. But for degrees, 2 or 3 sig figs is fine. Am I right? I did this in a hurry while I was multitasking. Yeah? And of course, there will be a second angle, whatever 90 minus 33.7 is, and that would be north and east. Yeah?
So I just for some reason back in my head, the 7.21 kilometers is just like Pythagoras here, right?
Yep, Pythagoras magnitude. So I went 4 squared plus 6 squared equals square root. Yep. Okay. And I'm, Spencer, being a tiny bit sloppy, I should always be putting a right angle there to make sure everyone knows it's a right angle triangle, because today we're going to run into non-right angle triangles, and then Pythagoras and SOHCAHTOA don't work. First of all, Deegan, how do we add vectors? Draw them. How do we subtract vectors? Well, the short answer is we don't. There is a subtraction rule, and when I was in university, this is how my prof taught it. We memorized. There is a rule to subtract vectors. You draw them tail to tail, and then the resultant goes from the tip of the longest vector to the tip of the shortest vector. But instead of memorizing an entirely new rule, we're going to be clever, because I'm going to argue that I can turn 5 take away 4, I can turn that into an addition question. 5 minus 4 is the same as 5 plus what? So instead, we're going to add the opposite. Rather than memorizing a whole new rule, why don't we just cleverly turn it into an addition? And then since we're adding, how will we add them together, Deegan? Draw them tip to tail. In vector symbols, we say this. If you want me to go vector A minus vector B, that's the same as vector A plus the opposite of vector B. And what do I mean by the opposite of vector B? Well, Shay, if vector B was originally north, the opposite would be? Yeah. If vector B was originally east, the opposite would be west. You don't change the magnitude. You don't put a minus sign or anything in front of it. Opposite, flip the direction to its cardinal opposite. So let's do an example. Example 2. Suppose F1 is 6.8 newtons due west stop. I've turned the page on electronically, so I'm going to do a compass rose because I just saw a compass direction in the question. And F2 is 12 newtons due north. What is F2 take away F1? I guess they want me to subtract vectors. I'm not going to subtract vectors. I'm going to add the opposite. So instead of doing F2 minus F1, I'm going to change that into F2 plus the opposite of F1. Eleonora, what is F2, magnitude and direction? F2. Yep. I'm going to draw that. So 12 newtons north, I don't know, 12 plus. What was F1 originally, magnitude and direction? 6.8 newtons due. So what would negative west be? East. Yep. So I'm going to point it this way. And now, Deegan, how would I add those two together? And that will give me the same as if I learned a whole new rule for subtraction. Solve it on your own. I'll do it up here. Let's see if we get to the same place. And probably around now, you're seeing what I meant when I said on the first day, you're going to get about as good at trig as you got at formula manipulation, where you kind of do one line and you're off to the races. Color, 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 color. North of south, east of west, what of what? The nice line is north, east of Kiana, you get the same as me? Yep. Okay. Don't write this down, but I think I told you there is an actual subtraction rule. You draw them tail to tail, so you would go 12 north, 6.8 west, and the resultant was from the tip of the shortest one to the tip of the longest one. You get the same thing that we drew, but why memorize an entirely new rule when I can change it into something I already know how to do, or at least most of us already know how to do. Is that right? Am I good? Where would you use this? I like example 3. I like example 3. Example 3 is a nice question. It says this. Suppose V final is 36 meters per second north. I've scrolled down, so I'm going to do a compass rose. And V initial is 17 meters per second east. What is, well, delta V, but what is that delta an abbreviation for? Yeah, change in. And here's the question. What's change in anything? Last year, had we had a normal year, I would have drummed this into your head, much like you all know, get the obvious one, gravity. This is a job for a free body diagram. I would have drummed in change in anything is something, change in velocity is acceleration. Sorry, change in velocity with respect to time is acceleration. So this isn't quite an acceleration yet. I'd need to know how long it took. But for what it's worth, change in anything is final minus initial. You might want to add that to your blue formula sheet on the front page somewhere near the top. The change in anything is final minus initial. Did you say minus, Mr. Dewick? This could be, if they're vectors, a subtraction question. Now, if they're scalars, you just go final minus initial, no problem. But if they're vectors, you better do some vector math. You can write it on the blue, you can't write on the yellow. The yellow one is the one you can't write on. The blue you can add anything you want to on.
Yeah, the yellow doesn't know how.
Yeah, that's why on the first day we wrote that. I've done this job before. I know my audience. Spencer, you walked into it, so let's do this then. If I want to find delta V, that's going to be V final minus V initial. No, it's not. Plus the opposite of V initial. What is V final? Magnitude and direction.
Is 36 north.
What's V initial originally before we muck around with it? Magnitude and direction.
That'd be 17.
So what's negative V initial? Still 17, but which is going to be to the left, and it's about half as long as the 36. I'll eyeball it. These are the two that I'm going to add together tip to tail. I kind of have to imagine this diagram a little bit. Annika, I started to draw, and then I went 17 over, and I realized, oh, I'm going to end up going around and through my equal sign. I need to move over. The 36, I need some room so I can come back. There's the 36. There's the 17. That right there is delta V. Did I say I like this question? I like this question. I like this question? I should have. Color, 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 color. Now I'm good. Delta V, change in velocity, equals Am I wrong?
Oh no, I just rounded my
25?
the 39 to, I guess.
Trying in your answers, try and go to 3 sig figs wherever possible. Mr. Duke, yes, Spencer. How come we're subtracting vectors? How come you went 36 squared plus 17 squared? If we're subtracting vectors, shouldn't we go 36 squared minus 17 squared? We're not subtracting vectors. We turned it into an addition question. It started out that way, but then we got clever. Said, why learn a new skill when I can easily, in my head, turn it into a skill that I already know? So how do we subtract vectors? We don't. We add the opposite. How do we add vectors, Deacon? Draw them. If you give me a slanty vector at an angle, can I give you the components that it came from? Yes. So we're going to talk today about vector components. Now, you did physics online. Did you do some vectors last year already then?
Yes.
Because, yeah, they've moved a lot of this to physics 11, which I think is dumb. Sorry for my YouTube viewers, but I'm not teaching the actual physics 12 and physics 11 course. I'm kind of smooshing them together. Vector components. We can break any vector up into its vertical. I'm going to abbreviate vertical with letter Y, like on a Y-axis, and its horizontal X components. For example, here's a velocity. It's 42 meters per second. It's being launched at 38 degrees. I don't know if we're looking at it from the side and up the page means up in the sky, or if we're looking at it from the top and up the page means north. So I'm not going to worry about north, south, east, and west. I'm just going to talk about vertical and horizontal, and I need a word problem with some context to figure out where we are. It says, find the vertical and horizontal components of this vector. Well, what I'm going to do is I'm going to draw a dotted line, d, 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 and I'm going to call that Vx for velocity horizontal component. And tip to tail, I'm going to draw a second dotted line, d, 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 and I'm going to call that Vy for vertical velocity component. Those must have been what I started with and added tip to tail to get the slanty resultant. Color, 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 color. Notice this time my triangle has 3 things. I'm going to label all 3 sides now. Oh, and that 42, opposite, adjacent, or hypotenuse. Yep. What about Vx? Yep. Good. What about Vy? Yep. If you need to write SOHCAHTOA at the top of the page, go ahead. Oh, and what do you want to find first, Vx or Vy? I don't care, pick. So to find Vx, I'm going to use those 2. The A and the H. Which trig function is the A and the H? Sorry?
Cosine.
Of course it is. Oh, and how would I get the Vx by itself? Yep. Multiply what? Yeah. Times that over. You okay with that? Yeah, yeah? Okay, let's write that out. But if you're comfortable in your homework writing this line down and going straight to the answer, I'm fine with that. Here, so that we know what we did, let's make a little note. Vx ended up being 42 times cos 38. It's going to be 33.1. It's a velocity, so it's meters per second. I'm not going to put a direction on. You know what the direction is? X. That's why I labeled it Vx. It's horizontal. Now, I could use Vx to find Vy. Don't write this down. why would I, if I'm a good test writer, try and avoid using Vx to find Vy? Yeah. Yeah, if I got this wrong, I'm getting the next one wrong. So, Parker, I'm going to use those to find Vy. Which trig function? Sine, what always goes next to the angle? Sorry, the trig function, the angle, Vy over 42. You know what? This looks identical to cos, except just a sine sitting there. How will I get the Vy by itself, Parker? You know, I'm so lazy, I'm actually just going to backspace on my calculator, if I have a good calculator, and change the cos to a sine. And I get 25.9. Rachel, here's what we're saying then. If I added 33.1 to, what was it, 25.9? This resultant should be 42. 25.9 squared plus 33.1 squared, 33.1 squared, square root. It's not quite, because of course both of these are rounded off values, and if I use rounded off values to find a new answer, I'll be off by a tiny bit. But if I had carried each of these to 5 or 6 sig figs, I'll bet you I would have 42.00002 or something. I'd be really, really bang on. Okay. And if I went and found theta, what was the original angle in the question that I gave you? I'd probably get like 37.96. Really close. So I can go backwards if you give me the slanty, the resultant. I can figure out what components it came from. And we're going to do that fairly often. In fact, if you're wanting a trigger phrase, did I say angle? Components is almost, do I see an angle? Components is almost going to be where we go. If we see an angle, we're thinking to ourselves, it's going to be components. We're going to deal with this. So example 5 says, find the components of this force, vertical and horizontal. This one's pointing down, so I guess I always draw horizontal first. And this time it'll be Fx, because it's a force. And then Fy, FYI. Color. Malcolm, that 39.6, opposite adjacent or hypotenuse. Yeah. What about Fx? What about Fy? Good. What do you want to find first, Fx or Fy? I don't care. Fx. So we're going to use those, A and H. Which trig function? Yeah, of course it is. Malcolm, how would I get the Fx by itself? You know what? Let's go straight to our calculator. 39. Whoop. Wow, what did I just hit? Cancel. 39.6 times cos 18. I get 37.6618. If I was using this to find something, I'd carry some extra sig figs, but they just said find the components and quit. So I'll go 37.7. Which trig function, Malcolm, to find Fy, FYI? Yep. In fact, Malcolm, can I just backspace and edit and change the cos to a sine? Cool. I like it when I can be both lazy and more accurate. 12.2. Mr. Dewick, it's pointing down. Shouldn't I call that like negative 12? You know what? The negative is in my diagram. I would clue in that it was pointing down. Yeah.
Will it always work out that like you can have one cos and then the equation will be the exact same for the sine with these kind of triangles? Like we just have the hypotenuse and we're finding.
No. Yes. I can't answer that question. This year, in the contrived nice questions that I'm giving you, yeah. Can I think of some yucky ones where it ain't? Yeah. And you know what? We'll have some coming up in a second where you'll see how it's pretty easy to get pretty complicated pretty quick. Okay. In fact, I think it's the next one. Yes. Example 6. I like example. Okay. I like example 6 and I don't. First of all, it says this. Components can help us add vectors that are not at right angles with each other. It wants us to add 14 newtons due west. I'm going to do a compass rose. To 24 newtons at 30 degrees north of west. Logan, do you see an angle? Components. That's kind of drilled into my brain. And also, it's going to be a lot of work. Now, there is a way to do this without components. Put your pencils down. Look up. Rachel, can you read to actually, Annika, can you read to me the first vector, magnitude, and direction? So I could go like this. 14 west plus, what's the second vector, magnitude and direction? 24 newtons. 38 degrees south of west? 30 degrees south of west? South of what? South of what? West. South of what? West. South of what? West. Not making fun of you. This is how you draw this. I'm going to go west first with a dotted line. That's my of. What of west? How many degrees? 30. And how long is this line? 24? Okay. Here's what I could do. Deegan, how do I add those together? Draw them. So it would look like this. 14, 24, where this angle is 30, and that's the resultant. Why can't I use Pythagoras here? It's not a right angle. Why can't I use SOHCAHTOA here? And in fact, I don't even have an angle in my triangle. Well, I could say, Mr. Dewick, that has to be 150 degrees because these form a straight line. And that absolutely is what I would do. There is something you can use here called the cosine law and the sine law. The cosine law says this: c squared equals a squared plus b squared minus 2ab cosine of big C, where that's big C and that's little c. And that totally works. And then you can use the sine law to find any missing angles. Sine of big A over little a equals sine of big B over little b equals sine of big C over little c. I'm ignoring your hand for a second. And that works. And I have actually, because you know I'm fairly lazy, counted the number of lines that I can do this method in. And I can do it in 2 lines faster than the method I'm going to show you. If you're totally good on the sine law and the cosine law, you can do it this way for full marks. You had a question?
Just go, you know it's 30 degrees on the outside, can you just make a 90 degree inside the triangle?
What do you mean by a 90 degree inside the triangle?
Not inside, but like, you know how it's 30 degrees on the angle on the outside is 30 degrees?
You're saying could you make that 60 degrees?
Yeah.
Wouldn't help you, because you don't know how that long is. But you're on the right track. What we, yep.
Because like the tangent of 150 is wait the sine of 150 is c.
You can get there, but I'm going to argue there's a cleaner way. It's about 2 lines longer, but it only requires Pythagoras and SOHCAHTOA. So you ready? First thing I'm still going to do is DULP. 14 west plus 24 newtons, 30 degrees south of west. South of what?
West.
I'm going to go west first. And then I'm going to go south of west, 30 degrees. And I'm going to ignore trying to be accurate to scale for a little bit. Which one is slanty and yucky? The first vector or the second vector? I'm going to break it into components. I'm going to call this fx and fy. Color, 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 color. That 24 opposite, adjacent, or hypotenuse. Fy. Fx. Let's find fx and fy. What do you want to find for? Doesn't matter. Let's go fx first. Liz, which trig function am I going to use to find fx? Cosine. It's going to be cosine of 30 equals fx over 24. I think it's going to be 24 cos 30. Is that right, Liz? Did you get 20 point? Now, since this is not my final answer, I'm going to carry some extra sig figs. And in fact, I noticed just after the 6, there's a 0. So I'll stop there. I'll go 20.7846. Which trig function is fy, Liz? In fact, I think it's going to end up being almost exactly the same pattern. In fact, I think it works out even. Do you get exactly 12? Yeah? Okay. So now, Shay, here's what we can say. I'm going to argue that the 14 plus the slanty is the same as, I'll even put an equal sign to turn this into like an equation. Still the 14 drops down like a domino. But I can go plus 12 plus 20.7846. And I realize we're adding 3 vectors, but remember I told you sometimes it's easier to add 2 of them together first. If I was clever, which 2 vectors would I combine first? The 2 horizontals. And even if they were in opposite directions, well, Deegan, then I would just go bigger minus small, winner minus loser, and combine them. In fact, I think I can do this in my head. 20.7846 plus 14 is 34.7846. On the next line, I'm going to say this is actually 34.7846 plus 12. How many vectors do I have now? 2. Are they at nice right angles to each other? Oh, now we're in business. Deegan, how will I draw them? You don't say. And now I'll try and go roughly to scale. So if I go 34.7846, 12's about a third of that, so I'll eyeball it. 12. And lo and behold, there is my resultant. And I was able to get there completely with Pythagoras and SOHCAHTOA, and I didn't need to bring out the sine law or the cosine law. Darn right we are. Race ya. Color, 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 color. I might be wrong. Am I wrong? I could be wrong.
Nope.
At least you got the same thing. Let me pause the video. By the way, notice those of you who remember your Physics 11, where it was often 2 lines and done, maybe 3 lines and done. What are we up to now? 1, 2, 3, 4, 5, 6, 8 lines. And that's going to be a regular occurrence this year. I would consider this a B+ level question. Okay. What would make it an A- level question if this was subtraction? What would make it an A level question if this was a word problem? We'll do one like that in a second. Now, I've made a decision. I told you I like this question, I like this question, I like this question. On a quiz, I've decided this year on your test, I won't give you non-right angle trig because it's just so much work, so many lines of writing. So I will quiz you on this. It'll be on most of your quizzes, at least one non-right angle triangle. But I won't hammer you on the test with that. Unless it's something as basic as just asking you to draw the picture, the vector diagram, and then walk away, but not do the actual number crunching. Okay. So here's a word problem. I like example 7, I like example 7, I like example 7 on a quiz because it's not right angles. How can I glance at this and tell instantly that it's not right angles? I saw a theta of 40 degrees. Did I say an angle? Components. See the 40 degrees in the question? This is going to be a trickier question because it's not right angled. A plane's engine speed is 240 meters per second due oh, nice try, Mr. Dewitt. Compass rose. A crosswind is blowing at 125 meters per second, 40 degrees north of west. What's the plane's velocity relative to the ground? So we're going to do the same thing as we did last day. On your formula sheet, I think I gave you that the engine velocity of an airplane combined with the way the wind pushes it, that's what gives you your ground velocity. I lifted that right from your formula sheet. Manraj, what's this question asking me to find? Which one? There's 3 of them, Captain Obvious. Okay. An A+ level question would be if I gave you the ground velocity and one of these and asked you to find the other one. What if I gave you the ground velocity and the engine velocity and said, which way does the wind blow? How would I get the V wind by itself? How do I subtract vectors? I don't. I have the opposite. And that would put everything together in one question. Okay, that would be totally fair game if it was right angled, if I made up really nice numbers, but I'm not going to hit you up with a non-right angle one. Right angled, then it drops from an A+ level question to about a B level question in my mind. Anyways, which way is the engine speed, magnitude, and direction? Wind speed, magnitude, and direction. North of what? North of what? North of what? And I'm doing that on purpose. When I draw these, of blank is what I'm going to draw first. I guess I'm going to go west first. What of west? So go back to where I started drawing. Go a little bit, well, how many degrees north? About 40 degrees. And that one is 125. And you'll notice right now I'm not caring much about scale because the 125 and the 240 look almost the same length because I see an angle. Did I say angle? Components. I'm going to break that 125 into horizontal, Vx, and vertical, Vy, components. Color, 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 color. Manraj, 125, opposite adjacent or hypotenuse. What about Vx? What about Vy? What do you want to find first? Okay. Which trig function to find Vx? So it's going to be cos 40 equals Vx over 125. What will I type into my calculator? Good, do that. I get 95.755, and since this is not my final answer, I'm going to use this to find the answer. I'll carry some extra sig figs. I'll go 95.756. I'll go to 5 sig figs before I round off. Hey, which trig function is Vy? Is it otherwise going to be the same? I'm running out of time, so let's cut corners a little bit. Let's go straight to our calculator and just backspace and edit. I'll go 80.348. So it looks like these two vectors can be rewritten as still 240 east, but it looks like I have a northern of 80.348 and a western of 95.756. Alicia, which two would I be clever to combine first? Yeah. Am I just going to add? Actually, no, I think I'm going to have to go winner minus loser here, aren't I? Can you see okay from back there? I'm writing as big as I can. Okay. Because you sat in the worst seat in the house there. And I don't mean just because of Liz. Okay. 240. That came out wrong. Or did it? 95.756. I guess I have 144.244 east. Yeah? So now I'll redraw this one last time. And now I'll kind of roughly start going to scale. 144.244, 144.244 plus 80.348. I've done the toughest part. Now I'm on familiar territory. Alicia, how many vectors do I have now? 2. Any suggestions on how I might want to add them? Tip to tail, you say? Oh, you are so much more cleverer than Pierce. So much. Make sure you haven't listened to the lesson and you know, I call him out, right? Nothing but a disappointment was he. Okay, here we go. 144.244 plus 80.348. Or again, you could go 80.348 plus 144.244. I'd give you full credit. I think this is going to be the plane's ground velocity. That's what the radar is going to see. There's theta. Color, 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 color. Pythagoras. And I get 165 meters per second at
My apologies, staff. Just
give me 1 second here. Let me just.
our
What'd you get for theta? 29 degrees? North of south, east of west, what of what? I'm not going to get to example 8. I'll start next class with that, but you don't need it for the homework. on a separate piece of paper, try every one of these. Some of these are a little bit tricky. Some of these are so easy that they're tough. So in number 1, you're just adding the following vectors. Number 2, you're subtracting vectors. Number 3, you're finding horizontal and vertical components. And then number 4, you have 2 non-right-angled triangle questions. So do your best, my angels. Here's another kind of cool application of vectors. It says this: an object is initially moving at 6 meters per second due east. I'm going to draw compass rose. It accelerates due south at 3 meters per second squared for 4 seconds. Find V final by using, many of you will remember from last year, VF equals VI plus AT. Everything that we did last year, Liz, works with two-dimensional vector mathematics as well. So let me show you what I mean. Annika, what's VI, magnitude and direction, according to this question? Direction? So VF is going to be VI plus A. Annika, what's the acceleration, magnitude, and direction? South, 3 south. And so what would 3 south times 4 be? What would 3 times 4 be? What would 3 south times 4 be? 12. What would 3 times 4 be? What would 3 south times 4 be? 12. My scale is terrible. The 12 should be twice as long. I'll fix that in my triangle. Annika, how can I add these together? Draw them. It would look like that. Where is theta going to go? Top left or bottom right? And now we're into familiar territory. It's going to be color, color, color. It's going to be Pythagoras. How big is V final? I guess V final is going to be 6 squared plus 12 squared square root. $13.4 at opposite, adjacent, once again it's tangent. So shift tan of 12 divided by 6, and I get 63.4 degrees. North of south, east of west, what of what?
South.
Yes, that's south of east. So one more example of a nice application of vectors. I don't know if I'm going to throw a bunch of stuff like that at you this year, but just letting you know it still all works. You just got to be a bit more meticulous.